Welcome. Here we'll take a look at using the inverse norm function on our graphing calculators to find a data value from a normal distribution. And here we're going to go ahead and work with standard normal. So we'll work with z-scores. And to find an unknown z-score, the inverse norm function will take care of that for us as long as we tell it the area to the left of that z-score we're trying to find. And then we include the mean and the standard deviation of the normal distribution. But again, we're going to go ahead and deal with standard normal, where the mean is 0 and the standard deviation is 1. And because that's the default on the calculator, if we do not type in a value for mu or sigma, it will assume that's what we would like to do. So we'll go ahead and use our standard normal here. So one last thing before we start, I will be working with my stat wizards turned off. So under mode, I'm going to come over to my calculator mode. I work with stat wizards off. So just a reminder, if you do have stat wizards, not everyone does, but if you do, you'll want them off if you want your screen to match mine as I step through my examples. All right, and then we will jump in here and take a look at some problems. All right, so I have some graphs of the standard normal distribution, and we are going to be looking for the z value that corresponds to the shaded area, and we'll round to 2 decimal places. All right, so the thing I don't know is this data value z. In this particular picture, I do know the area to the left of it. So I'm just making a note here that it's the area to the left of the z-score that has been shaded. So in order to find the z-score, so z, we always inverse norm that area to the left of it. So in this case, we just inverse norm 0.1314. And that's all there is to it. So we'll come to our calculator and we will go to our distributions. So second distributions, and then inverse norm 0.1314. We round that to 2 decimal places, so that is negative 1.12. I'll box that guy in and make sure the answer makes sense. So remember, with standard normal, 0 is in the center of the distribution, that's the mean, and that z-score is to the left of 0, so a negative answer makes sense. So always important just to give a quick check to see if your answers are reasonable. All right, so number 2, now the z-score I'm looking for, the area they shaded is to the right of that z-score. So in that situation, I'm just going to abbreviate here, area right is given as 0.2177. But I need to know the area to the left of that z-score. So we just use the rule of complements. So if you take 1 minus the area to its right, you'll get the area to its left. So that is 0.7823. All right, and I'm just going to go ahead and indicate that on the graph here. So all of that unshaded area is the area to the left of the unknown z-score. Sorry about that, 7823. All right, so now you can find the z-score. We always inverse norm the area to the left of the z-score we're trying to find. All right, so again on our calculator, second distributions, inverse norm, 0.7823, and that comes out to be 0.78. So let's make sure that answer makes sense. So there's 0 in the center, And a positive z-score does make sense because we're to the right of center. So I'm rounding to 2 decimal places, but don't think this is a percentage. It's not 78%. So z-scores are not proportions or percentages. These are just numbers on the number line. So on that number line, this is where I would be in order for that area to be 0.2177 and that area to be 0.7823. All right, so in summary here, all we have to remember is we're looking for a z-score. Just going to highlight. You have to inverse norm the area to the left of the z-score you want to find. So if I want that z-score, I inverse norm the area to the left of it. All right, we'll just do a couple more here. All right, so here's my z-score. It'll be a negative number because it's left of center. And they've shaded all this area to the right of it. So if they shade the area to the right, 9332, you need to know the area left of it. So you use the rule of complements. So that is going to be 0.0668. I'll just point to it this time. So that unshaded area 0.0668 is our area to the left. And so that's what we will be using in our inverse norm function. So inverse norm, the area to the left of the missing z-score. All right, let's make sure we get a negative answer. So inverse norm, 0.0668. And we get negative 1.50. And that seems reasonable then, negative number. I'm going to put it on my graph again. So negative 1.50. Okay, so area is always a positive number. It's the z-score that can be negative if it's left of center or positive if it were to the right of center. Okay, last one here. So there's my z-score I'd like to find. They've shaded all this area to the left of it. So if the shaded area is to the left, so if you know the area to the left of the z-score, it's 0.9871, then you go right to inverse norm, because inverse norm, we always inverse norm the area to the left of the z-score. All right, so in this case, we can inverse norm directly, and we better get a positive answer for z according to that picture. So inverse norm, 0.9871. Indeed, that is positive 2.23. All right, throw that on the picture there. And that is how you use inverse norm. And I've gone ahead and shown you examples where we're dealing with the standard normal distribution, but the same sequence applies for any normal distribution. We would just have to also include the mean and the standard deviation if it is a normal distribution rather than standard normal. All right, hopefully that's a good recap there of using inverse norm.